Hello, my name is Alan Clark. Thank you for joining today because I want to talk for a few minutes about the future of the automotive platform. I want you to remember the cartoon series called the Jetson and their futuristic lifestyles. Remember that? People in that future lived in housing in the sky. They drove aero cars that looked like flying saucers. And they had incredible conveniences that left them with plenty of leisure time. I remember in the show that they even had a robotic maid named Rosie and a talking dog named Astro. It was a memorable view of the future, especially when you consider that it was released in the 1960s. So when we look at their perspective of the future, it kind of draws the question, are we there yet? Well, not quite. Some of the gadgets they had are pretty good. Some of them we have today probably even outpace those. But I believe that we're still waiting for the flying car. Well, maybe not the flying part, but at least all the fun bells and whistles that we all want in a futuristic car. And some of those are beginning to happen. Driver Magazine stated, quote, "It takes time to develop and market new products, but automakers face an even longer timeline thanks to the complexity of designing, testing, and building a vehicle. While a new cell phone might be winging its way to its customers in a matter of months, an all-new or redesigned vehicle can take a minimum of 3 to 5 years." We get it. Of course, the critical certifications and rigorous assurances needed in an auto extend far beyond the traditional steps that are needed in a cell phone. But the auto industry is recognizing that it can deliver more by pushing past the traditional holdups of complexity and proprietary hardware and software, siloed design systems, inner complexities that they have with their current partner ecosystems, and in general, the ability to empower their software developers. So as you look at the global growth of vehicle sales, we can see that there is an opportunity for change. And indeed, the automotive industry is going through a significant transformation. Early stages of autonomous driving, the connected car, and electrification are no longer future ideas, but they are realities on the road today. The automobile industry is poised to invest $52 billion in automotive software for autonomous driving and connected features by the year 2025. That's a big chunk of change. As a result, the autonomous driver software market is expected to increase at a component annual growth rate of about 17% up through 2025. That's 30% of the car's value will come from its software by 2030. This shift has captured the interest of vendors and manufacturers in the forefront of reinventing the modern automobile. Connectivity and later autonomous technology will increasingly allow the car to become a platform for drivers and passengers, for them to be able to use their time in transit to consume novel forms of media and services, or dedicate the freed up time to other personal activities. The increasing speed of innovation, especially in software-based systems, is going to require that these cars be upgradable. As shared mobility solutions with shorter life cycles become more common, consumers will be constantly aware of technological advances. This is going to further increase the demand for upgradability in privately cars as well. The barriers are well known, the opportunity is evident, so what is the fix? Well, there's 4 things I want you to think about. 1, the need for a common technology platform. A platform that enables the centralized architecture and a consistent code base. 2, connectivity with the outside world. 3, the need to embrace cloud-native DevOps. 4, engage with the open source world. In essence, if we boil it all down, what we want is to simplify the platform, modernize the architecture and the development modes and models. And if we can do that, we can accelerate the time to market. If you look at the car today, over 40% of its cost is in the electronics. Those electronic components are in a response to us, to consumer demand. These components include safety, infotainment, navigation, fuel efficiency, and advanced features. Features like driver assist systems, security automation, solid-state lighting, transportation and energy management. With all the components, the infotainments and security that I just mentioned, those being added to today's car leads us to understand how the technological advancement of the auto industry is really a case study in need of simplification. 1968 introduced the first vehicle with a computer-controlled electronic fuel injection system. This first production automotive microcomputer, or what we now call an ECU, was a single-function controller used for the electronic spark timing. Of course, later advances led to displaying the speed, your fuel, trip information, and engine information. By the early 80s, microprocessor-based engine controls executed about 50,000 lines of code, and this had come and spread across the U.S. in all passenger car productions. It's in the last decades that we've witnessed a rapid adoption of increasingly complex software in automotive. Today's cars are no longer just about transportation. 10 years ago, only premium cars contained 100 microprocessor-based units, ECUs, that were networked throughout the body of the car, and they executed probably 100 million lines of code or more. Today's high-end cars with advanced technology like advanced driver assist systems may contain 150 ECUs or more, easily 150 million lines of code. Even the low-end vehicles are quickly approaching 100 ECUs. It's interesting to note that the wiring harness in the ECUs weigh around 80 kilograms or more. That's in the same ballpark as an electric engine. So we know the industry is undergoing a rapid technological change, driven by the need to address impending, ever more stringent CO2 and criteria emission regulations. They're doing that while sustaining an unprecedented rate of progress with development of automation and infotainment. They're really pushing to meet the customer's expectations regarding performance, comfort, and utility. All this growth and demand calls for a platform transformation. A platform that will reduce the number of ECUs to maybe a dozen by centralizing it into the car. It introduces the need for a zonal architecture to centralize the logic. It introduces the need for a platform actuates a networking backbone to reduce the wiring weight. And it introduces the need for a platform that can implement software-defined paradigms so that we can take advantage of things like over-the-air updates and all these new features. So what is needed is a transition from a hardware-defined to a software-defined industry, a platform built on open, a platform supported by industry-relevant software vendors, a platform built on standards for safety, reliability, and interoperability. Key to this approach is a platform of consistency and interoperable standards. By doing this, we can accelerate the development of new software. We can build the ability to handle terabytes of data in a secure, fast way, and we can attract talent, the software developers, from these existing large ecosystems. This is key to simplification. At the heart of software defined is a construct of containerization. Containerization, of course, as you know, is sweeping the technology sector, as containers address the need to have software run reliably whenever they're moving from one computing element to another, be it from a developer's laptop to a test environment to a staging environment into production and onto deployment. The benefits of using containers at the mobile edge include improved predictability, particularly with software functions that run the same way everywhere. Higher security. isolating microservices that use permission-driven interactions, the ability to enable software reuse with standards that guarantee operation within the environment provided, reducing complexity with common operations deployed on common environments, and again, greater consistency, using the same functions deployed every time. So as the basis for containerization and as a competitive advantage, players are using lightweight embedded Linux operating systems and Kubernetes to build integrated cloud-to-edge platforms that deliver connected car use cases and are exploring new business models. Linux is becoming the perfect fit operating system tied with commodity hardware to replace the proprietary microcontrollers. With Linux, the platform transitions from a hardware-defined to a software-defined industry. Such a motion will reduce fragmentation in the ecosystem, maximize the reuse of existing software, reduce the development costs, simplify the development environment, and reduce TTM for new products. The automotive sector faces challenges with software updates, especially in the areas like infotainment systems and navigation systems. I'm sure you've seen this in the current autos that you own. These types of systems impact the real business value of the maker, such as car warranty costs and car repairs. In the near term, automotive companies are exploring software over-the-air updates and firmware over-the-air updates. Longer-term opportunities exist. Think about the ability to transfer content to and from the vehicle and how you could use that. You could do things like insurance tracking, on-demand entertainment content, for example. So to be successful, automotive companies must deploy open, reliable, and flexible application platforms to the vehicle edge and develop cloud-based products that they can then monetize that data. So these examples illustrate the need for orchestration that simplifies deployment, operations, and management. Now, the open source Kubernetes container orchestration system is very well known for its use of unified standards, which provide consistent functions and experience across the ecosystem and across all these devices. Additionally, cloud-native technologies like Kubernetes have enabled developers to build lightweight applications using containers for the edge, and as we move forward, for the mobile edge. Now, K3S was developed by Rancher Labs, and it's a CNCF project. This is a key orchestration platform for these compact footprint edge platforms. As a Kubernetes distro built for the edge, it's lightweight enough to not put a strain on the devices for RAMs and CPU. But yet you can take advantage of the Kubernetes device plugin framework, for example. And the workloads running on top of these devices can access technologies like the GPUs and do so with efficiency. So with Kubernetes and with K3S, we have orchestration capabilities that we can tailor for quick and consistent application deployments. Orchestration that enables automation, enables scalability, and enables flexibility. We then, of course, need to bridge the gap between the developer world and the deployment world. The CICD Pipeline creates a common framework for all developers, testers, and of course the product managers that are working on a given software development project. It also reduces the amount of manual work. It helps catch critical bugs early and makes it easier to incorporate feedback early on. The CI/CD pipeline reduces risk by making it possible to deploy small incremental updates that can be rolled out gradually to many distributed edge devices. So any breaking changes, which may cause other components to fail, can be addressed quickly before they have any significant impact. So in particular, if we think about the benefits of using CI/CD out there at that mobile edge, first, we can get better code and faster releases with smaller updates that are easier to isolate and test and repair. We can get faster time to market for new features with quick rollouts and more responsive services. We can get smoother operations with cleaner code that has fewer non-critical defects. We, of course, get increased automation. This gives us the ability to deploy code to the production environment with the minimal human intervention. And of course, we get higher efficiency with more developer time available to focus on code quality and innovation. So it's interesting to note that what we're seeing with the DevOps movement is very much akin to a philosophy that's well known within the automotive industry. They call it Kaizen. Kaizen is a Japanese term meaning change for the better or continuous improvement. It's a business philosophy regarding the processes that continuously improve operations and involve all the employees. Kaizen sees improvement in productivity as a gradual and methodical process. With Kaizen, the concept of people involves making the work environment more efficient and effective by creating a team atmosphere. It's the ability to empower in a transparent environment. Notions that very much align with true open source principles, by the way. And modernization methods we discussed provide an excellent system and tools to be able to reach this effectiveness. Changes can come from any employee anytime and don't have to happen slowly. So as we build these solutions, we can recognize that small changes now can have big future impacts. As we evaluate the solutions through test, analysis, and deployment, we can see if the problem that we've solved actually works. And then, of course, Kaizen has the concept that there is no perfect end and that everything can be improved upon. This is, of course, the part where we need repeatability, because we believe that people must strive to evolve and innovate constantly. So as we overlay the Kaizen and cloud-native principles, we find that there's many, many similarities. And these similarities are what demonstrate that cloud-native principles will enable the mobile edge to change for the better through continuous improvement. And that we can achieve the advantages that cloud-native brings, namely, accelerated competitive advantage, expedited response to user and market opportunities, a boost to developer productivity, maximized infrastructure efficiencies, enhanced application portability, and of course, the fact that cloud native paves the way for edge computing. Now, I know that I've talked about many things. As I mentioned early on, we need to build on the advantages of open source. The key point of openness is the inclusivity, freedom, and flexibility that we need to build the platform of the future. Open source software within automotive allows car manufacturers to innovate on the base technology and implement those innovations. Open source enables us to tap into the vast resource of talent that exists today and is growing. The constructs of open source enable us to tap the experience and identify the needs all across the industry. And the principles of open source enable us to do these things through the industry open source projects and collaborative forums such as the recently announced SOFI. So now, how does SUSE fit into this mobile edge? SUSE actually has close to 30 years of leadership in true open source innovation. SUSE's goal has always been to give you the freedom to innovate everywhere. We're driven by the power of many. Everything that we do is empowered by the skills, creativity, and vision of our employees, partners, customers, and of course the communities that we're involved with. We believe that every business is on a journey of digital transformation, and that transformation can be enhanced and accelerated by open innovation. In today's hyper-connected world, innovation is occurring virtually everywhere, in the data center, in the cloud, at the edge, and even, yes, out on the wheels. We believe that most successful businesses will be those that capitalize on open and interoperable solutions, solutions that let them harness innovation, no matter where it occurs. That's why some of the most cutting-edge companies entrust SUSE with their mission-critical needs. That includes supporting the automotive industry with its hardened enterprise Linux solutions since 2008. Currently, 12 of the 15 largest automotive vendors run SUSE solutions. SUSE is exceptionally prepared to help each business choose open with the industry's most adaptable Linux and leading container management solutions. These provide full management of all Kubernetes distributions. Because SUSE is truly open, businesses can choose the right combination of technology and solutions to ensure their business success. That's why our mission is to help our customers innovate everywhere. The resulting solutions not only leverage the goodness and innovation from open source, but they also significantly provide consistency from a single unified code base, not only from the edge to the cloud, but across all major processor instruction set architectures. Key technologies include SUSE Enterprise Linux, including real-time support, SLE Micro, SUSE Rancher, RKE, K3S, which we talked about, Longhorn, and SUSE Manager. So I've talked a lot about SUSE, but what does this mean for the automotive platform for tomorrow's car? It means that we have the power of open source for automotive that's hardened, supported, and ready, and that is flexible, reliable, and secure. We have the value of open source software from the data center to the open road. It's indisputable, having been used in the automotive industry for over 10 years, including SUSE's experience in automotive with partners such as Electrobit. SUSE's expertise in edge computing in some of the most remote and resource-constrained environments are enabling organizations to build a common compute platform, again, from that core clear out to the edge. And it allows them to maximize their consistency and security, making testing more straightforward and allowing developers to move faster and more effectively. It means that we have trust and security from those embedded solutions, and we've been able to optimize that with an intelligent small footprint with the same enterprise-grade security capabilities that guard against attack, against fragmentation and corruption. And that includes certifications in those areas, things such as FIPS 142, and common criteria, and so forth. Then, of course, there's the Kubernetes capabilities at the edge, which I discussed just a minute ago. This brings the ability to easily transition to the latest cloud-native technologies, including Rancher, Longhorn, and K3S. SUSE has been a long-standing partner with ARM. SLES on ARM is the first generally available enterprise-grade Linux distribution tailored for devices with 64-bit ARM chipset, and is supported by a wide range of industry hardware. So again, SUSE's goal is to give you the freedom to innovate everywhere. We're driven by the power of many. We're driven by empowering you with the skills and creativity and vision that you need to make your business successful. So the need for transformation of the automotive platform is clear. It's exciting to see that the future is here today. SUSE is committed to helping foster this transformation that will build access to new markets and technologies, and that's going to accelerate innovation. SUSE, with its computing and management capabilities, global partner ecosystem, and open source, is uniquely positioned to build these solutions with our partners today. Solutions that are going to help our customers solve complex problems across a wide range of industries. Thank you for your time.